AI at the tip of your fingers. So my name is Gabriel Dittrick. I'm a machine learning and software engineer at Ubik, where I work on a vast number of subjects ranging from object detection to recommender systems, but also mobile development or even DevOps. I like cross-domain topics, and this is why this talk will be about mobile machine learning. So today we'll learn how to easily run machine learning on mobile using capacitor and TensorFlow JavaScript. So if you have any questions after the talk, you can reach out. You have my details below, or you can ask questions in the chat. So first, let's talk about Ubik. So Ubik is an all-in-one digital workplace for frontline teams. That means that we put an intuitive tool in the hands of our end users, and we provide data insights for the company admins on everything that is executed inside the app. And all of this powered by some AI algorithms to make it even smarter. So we build and maintain more than 10 applications that we ship to the mobile stores. For those who know Apple Store rejection rate, you're probably already impressed. And we also, of course, build for web platforms. And for this, we need a lot of developers. So we're recruiting all over the board, so backend, front-end, algorithms, so machine learning engineers, and we have people all around the globe. So if you're interested, you can go to our website, or you can also reach out. And if you're not a developer, we also probably have a role for you. So don't hesitate. Now, what is mobile machine learning at Ubik? So at Ubik, a company would be any client that wants to monitor a store to give the perfect experience to its customers and to track metrics that are related to their products. A user would be any employee of this company, and this user would go inside the store and he would take a picture of a shelf inside the store with his mobile device. Then the app would do a detection of the products that are present on the shelf, and we would compute some insights about those products. So those insights could be anything from the presence of a product, the position of the product, or even the share of this product versus the competition. All this is very fast. It runs in only a few seconds, and we can do it offline, which means everything is happening on the device. We're very proud of our lightweight object detection algorithm that is ahead of the market. None of our competitors have such a solution running offline. So now let's take a step back and give you a bit of context before we go further into the presentation. Part of the audience is probably aware of machine learning principles, and a big part is probably not, and that's okay. Remember the title of the talk, how to easily run machine learning on mobile. So we'll just have a quick overview of machine learning principles. So first, the data. In the example I showed you before, the data would be some pictures of shelves. So data needs to be gathered to do the training of your algorithm. And this data also needs to be annotated. So in the example of Ubik, this would be shelves images with annotation of each product. So what the product is and where it is on the shelf. Then there is the training step. So for the training step, you need to follow a procedure that will make the model better and better to perform a certain task. Then when you think your training is done, you can evaluate the model. That's where you make sure that this task is done well. And you usually have a training set and a validation set on your data. You just keep 10% aside of your data to try to make sure that your model is executing properly. And the last step is the inference. This is where you deploy your model to production and you run it on some unseen data. And this is actually where your model is bringing some value. So what we will focus on during this talk is the last step, the inference. This is where some actual code is running an algorithm on some new data. And for us, this will happen on the mobile. But why would we want to do mobile machine learning? First argument is that it allows you to distribute your AI feature directly on your client app. You do not need to set up any backend. It also allows you to train an algorithm directly on the device as part of the feature. A model can be improved on the go on the device, or it can even be trained from scratch, depending on the context and depending on the complexity of the training. Imagine a next word predictor algorithm on your keyboard. You don't want to send everything you type online and wait for the algo to train and run. You want this to be fast, and this is what mobile machine learning provides. Since the algorithm runs on the user's smartphone, all of his data can also stay safe on the device, and he doesn't need to send anything to the remote server. Coming back to this next word predictor, do you really want to send all the text that you're typing on your laptop or on your smartphone to someone else's server to be analyzed? And last but not least, you can run this algorithm offline, meaning that the user does not need an internet connection to use your app, which can often be challenging. The price of the data, you can have bad reception, you could be abroad, or you can even not have any connection at all. So those are the main reasons why we would want some machine learning running directly on your mobile. But mobile machine learning is great, but it also comes with some challenges. First, the compute power. You can compare it to running on a server. On a server, you would have all the power you want. You just have to pay for it, and then you can scale it. Whereas on a smartphone, you only have like 100 grams of device, and you don't want to walk around with a 10-kilogram laptop in your pocket. Then storage. The average Android app file size is around 11 megabytes. iOS is 35 megabytes. And the average size of a state-of-the-art object detection algorithm, so this would be the best-in-class algorithm for that task of detecting objects on a picture, it would be around 200 megabytes for 100 classes to detect. So as surprising as it can be, the most common reason for not downloading an app on your device is that you do not have any space left. So if you multiply the size of your app by 2 or by 10, you will lose a lot of users. Then the time of inference. You do not want to wait 10 minutes to know what word I will predict that you should type next. That might happen if you have to send it to a server. So if you're running everything on the device, that's a good argument to have offline machine learning. It will make your model run faster and your feature will be much faster. Then performances. You do not know in advance the model of device that your user have. And it could be an old Android phone, or it could be the latest iPhone 15X Pro Max Plus Retina. So you need to take this into account when you're designing your algorithm and when you're designing your app. So an advice is that you should aim to support a broad range of devices, and this means designing small networks. So you need to find a compromise between a lightweight algorithm that could run fast on any device without taking too much space in the storage of the device, but also compromise with the good performances, because you still want the task of your model to be performed correctly. So what are the technologies that we'll be using during this presentation? First, we'll be using Capacitor. Capacitor is an open source mobile framework developed by Ionic and also maintained by the open source community. It's web developer friendly. Most of the code and tools are for web developers. And you can also add more plugins if you need to access some native functionality of the devices. And note that this demo does not use any native plugin to run the machine learning. The only native plugin that is used is a camera plugin, because we still need to gather some pictures. So what we will do on this demo is an image classification app. So Capacitor is also cross-platform. It can be run on web, on iOS, on Android. As I said, it's developed and maintained by the Ionic team. Then we will use TensorFlow JavaScript. So TensorFlow JavaScript is based on TensorFlow. It's an open source framework for machine learning developed by Google. And it's mostly used with Python and also C++. But it can also be run in the web with TensorFlow JavaScript. And that means that if you're using TensorFlow JavaScript, you could run your model on any app that is using web technology. So that would be any website running Angular, React, Vue, or it can also be a mobile app running with Capacitor or even React Native. And that means that it can also run on the backend with Node, if your backend is based on Node. So this is quite important. It means that you can possibly have only one model that runs on every platform. And you would not have to repeat the code for running the model, and you would be able to only train one model. So that's quite powerful. So we've seen the steps of machine learning pipeline, and we've seen what technology we're going to use, capacitor and TensorFlow JavaScript, which are meant for web developers. Now let's talk about the demo that we will be building. So we'll be building an image classification app. That means that we'll have a mobile application where you have access to the camera of the app, and you can detect what object you present to the camera. So there is no detection, it's not object detection, so we don't need to find where on the picture the object is located. We just need to find what is the main object that is on the image. So it's a task that is a little bit simpler than object detection. So it's image classification. For this, we will use a MobileNet network. So MobileNet is an algorithm that was developed in 2017. Here I've put on the slide the paper, so the introduction of the paper that led to the discovery of this algorithm. And what I would like to put the emphasis on is that running an algorithm is not just code. There is a lot of math and data science and also computer vision that goes into designing an AI algorithm. So here we'll just focus on running the developed model, which is totally fine. You can find a lot of open source models online. For example, most of the research papers are by definition free to access, and you often find some code or some pre-trained models online for free. But keep in mind that for a specific task, you might need to develop your own algorithm, and it starts to be more scientific research than just development. So now let's dive into the code. As a reminder, we want to build a mobile app that will use the camera of the device, and this will run an image classification algorithm on the frames coming from the camera feed. And this will make a cool app that can classify objects. So for this, we will be using the Ionic command line tool, and we will be using Yarn as our package manager. The first thing we're going to do is that we're going to build a capacitor app template with the Ionic CLI. This will be a template that has tabs as the navigation, and it will use Vue as the front-end framework. And we're just using the Ionic CLI to build it. Then what we want to do is that we want to add the native platforms to our project. So for this, we are still using the Ionic CLI. So Ionic capacitor add command is doing two things. First, it installs the capacitor or the capacitor iOS package on your project, and then it creates the native iOS project in your app repository. So this would be the capacitor CLI command cap add iOS. And it would do the same thing for Android with the Ionic capacitor add Android command. So now that we have our project set up with a template app and that we've added the mobile platforms, we just have to build the app. So the first command is yarn build. This will build our web application. So this is the Vue application. This will create our app's web folder in our project. Then we're going to do yarn sync. Yarn sync does two things. First, it will copy your web folder to the native project. So the output of the Vue build, it will copy it to the Android and the iOS platform folders. Then it will also update all your native plugins. So if you've added any capacitor or Cordova plugin to your project, these will be synced to your native platforms. For now, we don't have any native plugin, but we will add one soon. And then we can do the mobile build. So for the mobile build, you can use the native IDE, Xcode, for example, for iOS. So you can just open it by running yarn cap open iOS. And then you will have your native experience with your Xcode, and you can just run the app on a device or a simulator. But you can also use the capacitor CLI to run the app directly on the device with the yarn cap run command. And boom, this is our app. So you can see here the template app provided by our Ionic CLI with the Vue framework. Okay, so now that we have our app, we want to update a little bit the content to make it more personal and make it a little bit nicer. So what you can see here is that we're going to update the main page template with some nice title and some text to make the app a little bit more personal, and we'll be using some Ion components. And this is what it looks like. So our capacitor edge AI app is created, and now we just have to add some actual features. The next thing we're going to do is that we are going to add the camera preview plugin. So the camera preview plugin will help us access the camera application of the device, and we'll be using this open source capacitor plugin, camera preview, that is quite nice because we can access the frames of the feed live to analyze them on the go. And we can also use it to put the camera feed in the background of our app. And we can, by doing this, add some visual component on top of the camera view. So it's quite nice if you want to add some indication that are related to your algorithm on top of the camera feed, especially if it's running live. So next, let's update a little bit our page template. So we'll be adding some buttons to start the camera, and also a button to close the camera. So this is what you see on the code on the top. And we'll also be adding two methods, one to start the camera and another one to stop the camera. And this is what it looks like when we open the camera. So now we have the basic of our app. We're still missing some actual intelligence, stuff that will recognize some products. So we're going to add TensorFlow to our app. The next step is to add the TensorFlow JavaScript package to the app. So this is where the fun begins and where we add actual AI. So the TensorFlow JavaScript package is containing the code that will do all the dirty work to run our machine learning model during the inference of our model. Now let's update a little bit our template. So this is the front end of the app. What we want to do is to show up a few information when our camera is running to tell the user what was detected in the app. So we're using an Ion card with 3 elements that will be displayed when the camera is running. First, the class that is detected. So this is the product that our model was trained on, and it's the product that our model thinks correspond the best to the image that we provide. Then the score. So this is a value between 0 and 1. This is just to make sure that our app is running correctly, and this is the value that corresponds to the best class that was detected. And also we'll be showing the time because we want to know if it's running fast or not. So we'll be showing this as well on top of our camera view. Then what we're doing is we create a detect method. So the detect method is doing a few things. First, it is using, if the camera is on line 91, the camera preview plugin to retrieve an image. So what it does on line 96, it's that it retrieves a base 64 image from the camera feed. Then we will create an HTML image element from this base 64. So this happens on line 98. With this HTML image element, we can then run the classification. So we're calling the classify image method on line 99 with our HTML image element. And this classify image method is coming from the TensorFlow examples. So what it returns is a list of detected classes sorted from the best detection score to the worst. So what we will then do is take on line 101 the best detection, and we'll decide that this is the class that was predicted, and this is the object that we want to show. Now, let's deep dive a little bit into the classify image code. So this one comes from, as I said, the TensorFlow examples repository. So it's the MobileNet example. You can find the source on the slide. And it was readapted a little bit with TypeScript to match this project. It takes one input. It takes the HTML image element that we created previously. And then the important steps are the following. First, we're creating an image variable from our HTML image element with the fromPixel method. So the browser.fromPixel method will take the HTML image element and it will create a tensor that has the shape of our image and that has values between 0 and 255. For those who don't know what a tensor is, you can consider it like a matrix, so a big array of numbers with a few additional mathematical properties such as transformations, but you can just see this as a matrix that will represent the pixels of our image. So pixels of each pixel is coded between 0 and RGB between 0 and 255, so it has 3 values. What we want to do then is to normalize this input image to make it match the inputs that our mobile network expects. So this is values between -1 and 1. And then we are also resizing the input to make it match the shape of the mobile network. And then we just launch the prediction and we retrieve the logits. So these are values that represent the classes that are detected, and they will basically tell us what is the best class detected. And let's see how it looks like. So here you can see on the app, when we launch our camera, you have some running shoes that are detected with a score of around 10%, and it runs in 60 milliseconds. So don't be confused by the score that is at 0.10 or 0.12. It's not a confidence score. You shouldn't be afraid that it's not close to 100. It just depends on how the model was designed and trained. And what's important here is that it's the highest score of all the candidate classes. And this is why the model predicts correctly the classes, so the class running shoes. And you can also see that the total time of detection is around 60 milliseconds. So that's more than 60 frames per second, which is quite fast. Now, let's just do a quick demo live. So here you can see the camera live. Let's go try to find a few objects. So here you can see this is a reflex camera. You can go to another class. Here, some sunglasses. And we also have our running shoes. If I stop the camera and put my front camera, you can see my face. You can see that it detects a jersey, but it does not detect any human face. This is because our model was not trained to detect human faces or human bodies. And now let's just wrap up. What are the main benefits of mobile machine learning? The first benefit is that it runs offline. So you do not need any network to make it work. And this will make your app more accessible, and also most of the time it will make it run faster. A big topic is also privacy, as we've seen. You can design algorithms and apps that will run offline without sending any personal data to a remote server. One of my favorite benefits of AI with Capacitor and TensorFlow.js is its simplicity. You only have one model running on all the platforms, so front-end, web, mobile, even back-end if you have a node server, and you only have one model that is trained. So two things that you're sharing: the model you only train once, and you share some code between your platforms, so you can have only one code that runs this model. And also a nice thing is that you can avoid some server setup and coding. Then a few things that you need to be careful of. First, the model size. You do not want to use all the space available on your user's device. Then the compute power. It can be quite slow on some devices, so you have to take this into account when you're designing your app and your algorithm. If you want it to run on a big range of devices, you have to be careful. So the best advice to tackle both issues is to design lightweight models. If you don't, your algo might be slow, it could crash the app of your user. So if you don't, your users will be pissed, you'll be pissed, and I'll be pissed as well. So please design lightweight models. I'll be watching. And a last point is model versioning. One caveat of offline machine learning is that your model is part of your app's code. So if you want to publish a new algo, a new version, you will have to publish it to the store every time you improve the algo. So if you don't want to push it to the store every time, and you think you will have to make many updates to your model, you should think about an update channel like downloading the latest version and caching it to the app. So in conclusion, Capacitor and TensorFlow JavaScript are great tools for a web developer to easily get started with mobile development and also machine learning. Thanks all for listening. This was my first talk at a conference, and I hope you enjoyed it. Hopefully you've learned something about AI and machine learning on the mobile. And if you want the source of the talk, as a reminder, I used an Ionic view as a starter app, and then I used the MobileNet TensorFlow.js example. And if you're interested in the math behind all of this, you can also go read the paper of MobileNet, and all the code and the steps of the demo is available on my GitHub. Thanks.